Today we'll write a Python program that creates a tuple storing the first 9 terms of the Fibonacci series. The Fibonacci series is defined like this. You start with 0 and 1. Then every subsequent term equals the sum of the previous 2 terms. So 1 would follow, then 2, then 3, and so on. Why a tuple and why exactly 9? The world may never know. First, we'll define a tuple called fib to hold the first 2 terms of the Fibonacci series, so fib has 0 and 1. After that, we'll loop 7 times because we have 2 terms of Fibonacci and want the last 7. So for I in range 7. Inside the loop, we just want to add on the next term, but this is a tuple, so we don't have an append function or anything. So we will have to do fib plus equals. We'll do the start of a single element tuple, so parentheses and a single comma. Before the comma, we'll calculate the next Fibonacci term, so fib sub negative 1 plus fib sub negative 2. This works no matter how big the tuple grows because negative 1 and 2 are always the 2 most recent terms in the series. Outside the loop, if we print fib and run the code, you'll see the first 9 terms of the Fibonacci series in a tuple. This method works but is doing something highly efficient. On this plus equals line inside of the loop, every single time you run this line, the code is creating a new tuple and copying all the elements from the old tuple into the new tuple, which we do not need to do if we go about this slightly differently. We'll change fib to be a list. Outside the loop, before the print, we'll do fib equals pass fib to the tuple constructor. That way, fib will end up a tuple. Inside the loop, we'll now do fib.append fib sub negative 1 plus fib sub negative 2. If we run this code, you get the same result, but have utilized way less unneeded memory. This has been Jacubication. Like and subscribe to learn more.